In the previous session, we discussed about quantum number and we understood that quantum number is giving address of an electron inside the atom. So again, we are continuing the application of quantum number in this lecture. Now we know that, student, there are 4 different type of quantum number. Like if you will see n, which is called as principal quantum number, and the range of principal quantum number that start from 1, and it can be what till n. Principal quantum number indicates number of shells. Like if there is 1, it is k shell. If n is equal to 2, it is L shell. If n is equal to 3, it is M shell, and so on. L is called azimuthal quantum number, and the range of azimuthal quantum number is 0 to n minus 1, where n indicates principal quantum number. For every shell, there is a fixed number of subshell, and that is indicated by L. There can be n possible values. ML is called magnetic quantum number, and the range of magnetic quantum number is minus L, 2 plus L, and formula to calculate is 2L plus 1. It indicates number of orbitals. Like the principal quantum number indicates about shell, or you can say it is nothing but orbit, or you can say it is nothing but energy levels. Azimuthal quantum numbers talk about the type of subshell, and magnetic quantum number talks about number of orbitals. Now this is spin quantum number. There are only 2 values given for spin quantum number, that is minus half and plus half. So minus half is for spin of electron, that is up spin, and plus half is for down spin. Now we know that if L value, let's say if L value is 0, 1, 2, 3. So if L value, that is azimuthal quantum number, is 0, that subshell is S. 1, that subshell is P. 2, that subshell is D, and 3, that subshell is what, F. For S subshell, the number of orbital is 1. So it is indicated as 1 box, and 1 box, that is 1 orbital, contain maximum 2 electrons. That is referred as capacity. So in short, capacity of S subshell is 2 electrons. For P subshell, there are 3 orbital, and this 3 orbital is indicated by 3 box. So 3 box means 3 orbital, and the capacity of P subshell is of 6 electron. For D, if you will see, D is consisting of 5 orbital. It can be indicated like 5 boxes, 1, 2, 3, 4, 5 boxes. And for D, the capacity of electron is 10 electrons. For F, there are 7 orbitals, that is 7 boxes, you can say 1, 2, 3, 4, 5, 6, 7, and F subshell has capacity of 14 electrons. One more time, S subshell has capacity of 2 electrons, P subshell can accommodate 6 electrons, D subshell can accommodate 10 electrons, and F subshell can accommodate 14 electrons. Student, if you will see this part, how the quantum numbers are, various quantum numbers are distributed for a given shell. This side I have written n. Now n means what? It is principal quantum number. So if n is 1, so the name of the shell is k. For k, if you will see, there is only one L value. This L is indicating azimuthal quantum number. There is only one L value, and that is expressed as what? 0. So the orbital for L value 0 or the subshell is what? S. But this is first shell, that's why we write 1s. Now orientation of s orbital, for all s orbital the magnetic quantum number is what? 1, and that is expressed as 0. So number of orbital for s is 1 because there is only one magnetic quantum number. If you talk about second shell, student, so for second shell, if you will see, that shell is referred as what? L. For L, the azimuthal quantum number is what? 0 and 1. So for 0 we write S, and for 1 we write what? P. But this we talk about second shell, that's why for this S and P, the number which is given is what? 2S and 2P. For S there is one magnetic quantum number, and for P there are three quantum number. So for S there will be one orbital, and for P there will be three orbital. If you see the third shell, which is referred as M, for M shell there are three L values. One is 0, one is 1, and one is 2. So for 0 it is S, 1 it is P, 2 it is D, and it is third shell, so the number is common, it is 3s, 3p and 3d. For s, again one quantum number, so one orbital. For p, three quantum number, three orbital. D, five quantum number, so five orbital. If we talk about fourth, it is what? N, and the L value for N is 0, 1, 2, 3, as well as what? So for 0 it is S, for 1 it is P, for 2 it is D, and for 3 it is F. Since it belongs to fourth shell, so the number will be what? 4. Every S has one magnetic quantum number, so there will be one orbital. Every P has three magnetic quantum number, so 3 orbital. Every D has 5 quantum number, so 5 orbital, and every F has 7 magnetic quantum number, so 7 orbital. For any electrons, student, all set of magnetic quantum number are not same. For example, when you talk about first electron, so the question is that where this first electron enters? First electron enters into K shell. Am I correct? For K shell, what is the value of N? It is 1. For K shell, for first electron that enters into S subshell, so what is the value of L for S subshell? It is one quantum number, that is expressed as 0. For S, what is the magnetic quantum number? That is 1, and again it is expressed as 0. So for one electron, the spin is given what? -12. So for this electron, if you will write the value of N, L, M and S, so its value is what? Value of N, L, M, S for first electron, so it will be what? It will be 1, it will be 0, it will be 0, and it will be +12. Let us try it for the second electron. Student, if you see the second electron again enters into the K shell. For K shell, the value of N is what? 1, and again it enters into the same subshell, that is S. For S, the L value is what? 1, that is expressed as 0. For S, again the magnetic quantum number is 1, and that is expressed as what? 0. But for this, now the spin of electron is what? +12. So if you will see, again N value is what? 1, L value is what? 0, M value is what? 0, and S value is what? -12. So for this two electron, if you will see, they both electron enters into the same subshell, that is 1s. So if two electrons are present into the same subshell, that is same orbital, then its three quantum number are same. Can you see? The N value for first electron, second electron and third electron. First electron and second electron, the N value, L value, M value same. The set of three quantum number is same, but spin quantum number is what? Different. So please remember, in one orbital there will be two electrons, and for This 2 electron, the spin should be what? Opposite. So with the help of quantum numbers, we can understand the modern approach or modern structure of the atom. So overall, if you'll see how this story had started, initially the science had told matter, whether it is solid, liquid or gases, it is consisting of large number of the particles, and if this matter is broken continuously, then you will find small particles. If you select this particle and again if you try to cut, at some point you will find smallest indivisible particle, and that had given the name what? Atom. After the knowledge of this, science discovered subatomic particle which was present inside the atom, and this statement, the knowledge of the statement was ruled out. The very first concept and the model of the atom was considered as what? Atom is what? Spherical in shape. It was the first concept. And after that, atom was treated as what? In such a way that it is consisting of subatomic particles, only protons and electrons, like plum pudding model or watermelon model. After that, if you will see, the modification was done. It was said that electron is continuously revolving around the nucleus, and this electron which are continuously revolving around the nucleus were termed as what? Shells, orbits or mere energy. But as per quantum mechanics, if you will see, only the electron clouds were seen around the nucleus, and it was termed as what? Orbital. So if you will see the development of model of atom, presently we have to go through with the quantum mechanical model. There is quantum mechanical approach, and this can be explained on the basis of quantum number, that is N, L, Ml and S. I mean, if you want to actually visualize the atom on the basis of quantum number, so this is the actual picture that how the atom looks. Yes, it is very complicated structure. Whenever we talk about atom in this 11th and 12th standard, so this is the actual visualization of the atom we should have, student. Let's start with this, student. Can you see? This is the center of the atom, which is nucleus, and outside the nucleus, if you will see, there are various circular paths which are referred as what? Shells. These shells have given name as well as what? Numbers. If you will see, this is the K shell, this is L shell, this is M shell, and this is N shell. For K shell, which is the first shell, the N, which is called as principal quantum number 1, L shell principal quantum number is 2, M shell principal quantum number is 3, and N shell the principal quantum number is 4. Let's talk about till 4 shell, though atom is consisting of N number of shells. Now after this, if you will see, N, that is principal quantum number, describes only the shells. The second quantum number L, that describes what? Subshell. So the K shell is consisting of subshell, that is 1s. L shell is consisting of 2 subshell, that is 2s and 2p. M subshell is consisting of 3s and 3p. And 3d and N subshell is consisting of 4 subshell, that is 4s, 4p, 4d and 4a. So can I say every shell has equal number of subshell? Further, this subshell is divided into orbital, and information of the orbital is given by M, that is magnetic quantum number. So S subshell is consisting of one orbital, and which is consisting of one box, and it is having spherical shape. Again, S is consisting of one orbital, spherical shape. But if you will compare, this is 1s and this is 2s, So 2s electron cloud, spherical electron cloud is bigger than 1s. For 2p subshell, there are 3 magnetic quantum numbers, so 3 orbitals, and the shape is what? Double shape. So this part is indicating first shell is consisting of 1 orbital, second shell is consisting of what? 2 orbital, s and p. Third shell, if you see, it is consisting of s subshell, p subshell, d subshell. So s subshell, so 1 box 1 orbital, p subshell 3 orbital, and d subshell 5 orbital. You can see now the 3s spherical electron cloud is larger than 1s and 2s. Now this 2p, this 3p is larger than 2p, and it is 3d, which is larger than 2s, 3s and 3p. So this shell is consisting of only s orbital, this shell is consisting of s and p orbital, and this shell is consisting of s, p and d orbital. Fourth shell is consisting of 4s, 4p, 4d, 4f, and this is, if you will see, 4s orbital, this is 4p orbital, and this one is 4s, so this is 4p, and this one is what? 4d orbital. You got this? So first division is what? Shell. Shell is divided into subshell, and subshell is divided into what? Orbitals. So whenever the atom is said, we have to visualize the structure of atom like this.